Hello everyone, this is Saritha, Assistant Professor, Department of Mathematics, Kaveri College for Women, Autonomous Trichy. In this video, we are going to see deterministic finite automata. First, let us see what is an automata. Automata theory is a study of theoretical computer science which says how a machine works inside the computer. First, we should know some basic ideas about the automata. Normally, machines are called as automata, and the plural of the automaton is denoted as automata. Next comes the finite state machine or finite automaton. Finite state machine is a machine which we use in our day-to-day life. It has a limited memory. Say for example, if we take microwave oven, it has a processing button. As soon as we start the microwave oven, when it is brand new, its starting state is off and we press the processor button, it goes on to the on state. After finishing the process, again if we press the button, it moves on to the off state. So this is a simple machine which we can give an example for a finite automaton. Next, we can elaborate this with some other examples. If we take an input string as a weather data, that is, if the heat wave is more than 45 degrees for 2 consecutive days, the Meteorological Department of India says heat wave occurs in that year. Now, we are going to calculate whether the heat wave occurs in that year or not. For that, first we have to take Q0 as a starting state, and if we have the temperature more than 45 degree, it moves on to the next state Q1, and we have to verify the other day also has the temperature greater than 45 degree or not. Again, if it has a temperature greater than 45 degree Celsius, then the heat wave occurs in that year will be confirmed because we have taken here the 2 consecutive days with the temperature more than 45 degree. Suppose if the heat wave does not occurs for the second day, we have to move from the Q1 to Q2 again. Then we have to do the process again. And if the heat wave have occurred, then surely the degree less than 45 degree also will be there in Q2. And if it is greater than or equal to 45 degree will also be in Q2 because already the heat wave have occurred. So now we are going to convert the given data into a automata with the input string as 0 and 1. If the temperature is more than 45 degree, we can denote that by 1. And if the temperature is less than 45 degree, we can denote that by 0. So we have an automata here which we have constructed, and with this we can determine a language. That is, if we have start from here Q0 and we reach Q2, which is the final state, there should be 2 consecutive ones. Otherwise, the heat wave doesn't occur. So the language is given with the set of all strings with 2 consecutive ones. So the language will be given as 110, 111, 011, and etc. So the strings are accepted by the language now. Let us see the formal definition for deterministic finite state automata. So first, we are taking A to be of 5 tuple element, which has Q0 is mentioned as the finite non-empty set of states, which is given in a set bracket as Q0, Q1, Q2, and sigma is a input alphabet, which is given as AB. It may also be given as 0, 1, and the capital alphabet A, B, etc. And the transition symbol is denoted as delta, which is given here by delta of Qx equal to Q. It means that if we take here Q, delta of Q0x equal to Q, we have to start from Q0. You have to read the string X and you have to reach the next state Q. The string is given here as A, B, B. The next one is the initial state, which is given as Q0. And it is mentioned with the arrow mark in the left. And the next element is the final state, which is denoted by F, and it is denoted in the transition diagram as double circle. Next, we are going to see some examples for this deterministic finite state automaton. If we take the example with the initial state as Q0 and the Q is given as Q0, Q1, Q2. If we take the string sigma, that is mentioned here as AB, and the final state as Q2. Next, we are going to take two strings A and A, B, triple A triple B, B, and we are going to check whether the string is accepted by the deterministic finite state automaton or not. First, let us take the transition functions, which is given in the table like this. So now we are going to take the transition diagram with the Q0 and then Q1 and Q2. Next, here we are having a function Q0. It goes from Q0 to Q0. We have to take the input symbol as A. That is given here as like this. And then it moves from Q0 to Q1 with the input symbol B. That is denoted as like this. And then we have Q1 to Q2 with the symbol B. Q1 to Q1 is denoted as A, and Q2 to Q0, we are not having any alphabets here. So we have to move from Q2 to Q1. So that is given here as like this. So by using this, we are going to construct an automaton which is accepted by a string or not. First, let us take a string as XABB, for which we have drawn a transition diagram like this. So here my string is A, B, A. I have to start from Q0. I have to reach Q2. So that is my final state. If I reach the final state only, the string is accepted or the string will be rejected. So first, let us start from Q0. If we start from Q0, we can able to read A. Then if we move from Q0 to Q1, we can use the string B to read, and Q1 to Q1 is read by A. Then at last Q1 to Q2 by A. Finally, we have reached the final state. So we can say that the string is accepted by the automaton. Next, we take another string, that is x is equal to A triple B B. Here we are having again the transition diagram. Let us start from the string A. So it starts from Q0 to Q0. Then it reads from Q0 to Q1, the letter alphabet B, and it goes on to Q1 to Q0 with alphabet B. That's all we can read. Other transitions are possible. That is, we have to read again from B to B. So it will form a loop like this, and it does not reach the final state. So the string is not accepted by the automaton. That's all the video. Here, I think you have all understand the concept behind the video. Thank you so much.